Hey guys, just a little video here reviewing the pH scale that you guys would have learnt about last year in Year 10. So a lot of these will seem familiar. So it's just a quick recap of what the pH scale is. If we look at what the pH scale, or what pH stands for, it's the power of hydrogen. So it looks at the fact that something with a large amount of hydrogen ions is going to be acidic. Okay, and as we reduce the amount of those hydrogen ions, they become more alkaline or basic. Okay, so we've got obviously this scale here runs from 0 to 14. Some scales are 1 to 14, not too much of a difference, just as long as we're in the ballpark. So obviously it's split up into three separate areas. We've got acidic, neutral, and alkaline or basic. Okay, so if we look down here, and obviously the acidic end is 0 to 6. So if we're looking at a strong acid, we're looking between 0 and 2, and then basically weak acids are 4 to 6. Okay, so obviously those are dependent on the number of hydrogen ions present. In the previous video I said down here we'd have an excess of hydrogen ions, and then up here those hydrogen ion concentrations are reduced. Okay, if we look in the middle here, we've got green for neutral. So we're looking at the fact that a neutral substance has an equal concentration of H plus ions and OH minus ions. And we've already discovered that when we combine those two together, they form the product of water. If we move on from 8 to 14, we've just got different shades of blue. Sometimes this will be more of a darker blue, but nevertheless we're going right up to purple. So again, 8 to 10 is sort of a weak base, and then we've got 12 to 14, which is a strong base. Okay, again, at the top of this scale, we're looking at the fact that these ones at 12 to 14 have an excess of OH minus ions, and if we look at the bottom of the scale, that excess of OH minus ions reduces, therefore reducing the concentration of OH minus ions. So you can see there's some everyday substances there that we can measure the pH of. Alright, so surprisingly our stomach acid is around about 2. It says 1 here, but it's a 1 to 2. Okay, so our stomach acid is very strong. If we look at the 0 to 1 area, that would be the lab acids that we have. Okay, if we move up the scale here, so our blood, slightly basic, but if we look at something around the home, we'd be looking at baking soda. As we move up the scale there, we've got drain cleaner. Okay, so drain cleaner is basically just sodium hydroxide, which we have in our lab. Okay, so when you're testing, these are the colours that you will find when you're using testing substances with universal indicator. Okay, so obviously if you match with universal indicator either as a solution or as a paper, okay, you can match it up to these colours, and that's the approximate pH that you'll get. Obviously, just to recap, strong acids down this end, weak acids, neutral, weak bases, strong bases, and we're looking at the fact that we've got an excess of OH minus ions down this end, an excess of H plus ions down this end, and then we've got an equal amount, which actually cancel each other out, an equal amount of H plus ions and OH minus ions that cancel each other out to form, well, pure water. Okay, well, thanks for listening to this video, and I'll have some activities for you to do via the assignments tab, and then the next lesson will focus on measuring pH. Thanks very much.